Alright guys, in this unit we're going to talk about covalent bonding. We talked about ionic in the last section, so now we got to talk about exactly what covalent bonding is. Okay, so again, if we look at our staircase, and remember this staircase, we've talked about it like a million times already this semester. For ionic bonds, things over here, we had metals. Okay, and we said that if everything was non-metals, which is stuff on the right-hand side, that it doesn't form ionic bonds. Instead, it forms covalent bonds. So that's what we're going to be talking about in this section, are things that are over here to the right of the staircase. Okay, so if everything in it is to the right of the staircase, it forms a covalent bond. So here's the biggest difference. First off, right off, what's the difference in the bonding? The difference is this, that the electrons are shared in covalent bonds instead of them being transferred like they are in ionic bonds. In ionic bonds, what we would have done is I would have taken an electron and moved it over here to make stuff happy. That doesn't work in covalent bonds. So if everything's non-metals, what happens instead is this, that they're basically going to slide close enough together that their orbitals are going to overlap. And then what's going to happen is that the electrons then can go anywhere they want between the two of them. We usually sort of consider them as being in the middle so that they belong to both, but really they can go wherever they want. Okay, but they're shared. That's the important thing. That's how they're going to get to the noble gas electron configuration, or we would say to the octet rule. Now, hydrogen, remember, is an exception. Hydrogen doesn't need 8, it only needs 2. Okay, these are what we call molecules. Okay, we call them formula units for ionic compounds, but in the case of covalent compounds, we're going to call them molecules because they actually exist by themselves. H2 molecules are just an H2. There's not thousands of H's all hooked together in this crystalline structure, and H2 is just an H2 on its own. Okay, so how does this work basically? How do we make this work? So here's the steps. Okay, so we're gonna work on our first molecule that we're gonna draw is F2. Okay, so a fluorine molecule consisting of 2 fluorine atoms. So we draw our Lewis dot structure, and yes, these are some huge dots, obviously I didn't draw those in, and we got 7 on each. Okay, and so we arrange them in such a way that we want to have them to follow the octet rule. Now, the only way that that's really going to work is like this. I'm going to basically slide them over so that they overlap. And then what you can see is if I circle just one of them, okay, so let's say I do this one right here, it now has 8 valence electrons. And conversely, if I circle the other one, okay, and only get the ones that are shared, then it also has 8 valence electrons. And the way it works is that the electrons that are in between them, okay, hold on, let me erase this real quick. The electrons that are in between them, which would be these right here, they count for both of them, okay? And so we draw them that way. So I've put my valence electrons around there, okay? And then instead, the way I'm going to draw them is so that those 2 electrons are in between them and they are shared. Now what we're going to do is we're going to call those 2 electrons there, those 2 in the middle, they're shared electrons, and that forms a bond. And so the way that we write that then is like this. Okay? A bond, or the 2 electrons that are shared in between them that form the bond, okay, those right there, those are the 2 electrons that make up a covalent bond. So that is what we're going to call a single covalent bond. Okay? So let's work on drawing a few of these. So first off, we can have double and triple bonds as well as that single bond. So let's talk about O2, which is the stuff that we breathe in. So I've got 2 oxygens. Okay? They each have 6 valence electrons. Now, I know that I'm drawing this a little unorthodox, but you'll see why here in a second. What's important is that I get all 6, okay? And then what's going to happen, the easiest way to always draw the bonds here is to take the single electrons first and to draw a line between them, and those become the bonds. Okay, and so then when we sort of clean this up a little bit, it becomes like this. Oh, if only I could draw individual electrons, okay? So it's going to look a little bit like this. I've got 2 bonds in the middle, okay, a double bond, and then around the outside, okay, I've got the lone electrons. So these are the lone pairs, we'll call them, okay, and these are the bonding pairs. And so this is a This is a double bond, and it has 4 electrons because each line represents 2 electrons. And so what you always do at the end is, first off, you have to count how many electrons you started with. Okay, so in this case, each oxygen brought 6 electrons, so I have 12 total electrons. And then what I'm looking for at the end is, do I have 12? So I've got 2, 4, 6, 8, 10, 12. And then do they each follow the octet rule individually? So 2, 4, 6, 8, 2, 4, 6, 8. So everybody's happy, follow the octet rule. That's my correct structure. Okay, let's do a triple bond here real quick. Nitrogen is a good example of this. Okay, each nitrogen is going to bring 5 valence electrons. Okay. Oh, someday, I will not do that, and I will save myself some time on those. Okay, so 5 valence electrons, so that means that I have 10 total electrons. So I'm going to go ahead and write that at the beginning just so I know. Then I'm going to just start drawing the bonds. So single to single, single to single there, and then those singles over there. And then if I clean that up a little, okay, what I get is nitrogen with 3 bonds in between it, and then a single lone pair around each side. Now, do I have the right number of electrons there? Okay, I've got 2, 4, 6, 8, 10 total, so I'm good. I've got 2, 4, 6, 8 for this nitrogen, and then I've got 2, 4, 6, 8 for this nitrogen. Okay, so everybody's happy. All right, so let's draw some other ones. That obviously is pretty simple. If we got 2 atoms, I mean, it doesn't seem like it's too difficult to figure out how to draw those. So what happens then when we have more than 2 atoms? We've got something like methane here, where we got CH4. So here's the way it works. Usually the first element is the central atom. Not always, but I'll give you a big hint. If you have carbon, carbon always goes in the middle. Always, always, always. So I'm going to draw my carbon, and it has 4 valence electrons. And then if you've got carbon and hydrogens, which a lot of times you will, draw your carbons, and then put the hydrogens around at the points. Okay? And hydrogens, remember, have 1 valence electron. Remember that they don't need to get to 8. They only need to get to 2. Okay, because that's all they can hold. So we got those drawn out. So that means I have 8 total electrons. Okay, and I'm going to connect the dots. Okay, the single electrons, I'm going to bond them together. And so I get a structure that looks like this. Now, in this case, it's kind of cool because the only electrons that I have are all tied up in bonds. And so I count to see that I have 8, 2, 4, 6, 8. Okay, remember every bond line counts for 2 electrons. And then you want to see if you satisfy the octet rule. So the carbon has 2, 4, 6, 8. So it does. Every hydrogen should have 1 and only 1 bond. If it has more than 1, then you did something wrong. Okay, so not too bad so far. So let's work a slightly more complicated one. If you've got more than 1 central atom, so like in this case I have 2 carbons, here's what you do. Just line them up. Okay, so I've got 2 carbons. They each have 4 valence electrons. Okay, and so I'm going to line them up, and then the first thing I'm always going to do is I'm going to draw at least 1 bond to connect them, so I don't forget to do that. All right, then I'm going to take my 6 hydrogens and I'm going to put them again at the points around the carbons. Now this doesn't always work because it's not always hydrogens that you're bonding, but if you got carbon, you should always put carbon in the middle and then just put the other stuff around the outside of it. And usually that will work out okay. You may have to shift some stuff around, but that's typically the way it works. So then I'm going to draw some bonds. Okay, remember we're trying to bond the single stuff together first. So if I clean that up a little bit, I've got CH, okay, bunch of bonds. That's an H, not an A. I believe we've had that difficulty before with my writing. Okay, and then we want to check and make sure that we've got the right number of electrons. So each carbon brought 2, so 2 times 6 is, or I'm sorry, each carbon brought 4, so 2 times 4 is 8, plus 6, so I should have 14 total electrons. So 2, 4, 6, 8, 10, 12, 14. Then we check the carbons to make sure that they're satisfying the octet rule. 2, 4, 6, 8, 2, 4, 6, 8. Everybody's good. All the hydrogens only have 1, so we follow the octet rule. Okay, now this would work too. I mean, if you had 3 carbons or 4 or 8 or whatever, just line them up, okay, bond the carbons together, and then put the other stuff around the outside. Okay, we're going to do one more quick example here, and then we'll try some of these out together and on our own. So this one looks like it's really complicated, and I know this is one of these cases where you guys always look at this and you're like, why in the world would they not just put this H here? Why wouldn't it just say C2H6O? Well, here's the thing. When you're drawing structures, the reason that we write formulas like this is that this gives me a clue to the structure. This tells me that I have an oxygen with a hydrogen bonded to it. Okay, that's what that OH there tells me. Okay, and that's really useful information when we start to draw this. So otherwise, we're going to draw this like normal. I'm going to start with my two carbons. Okay, carbon always goes in the center if you've got carbon. Okay, 4 valence electrons around each. I'm going to go ahead and bond that together. And then I'm going to put those 5 hydrogens, okay, these 5, I'm going to put those around the points. Okay, so that's 5 hydrogens around the points. And I can be pretty safe right there in saying, okay, I'm going to bond those. Pretty good so far. And then I've got an OH. So the fact that it's off to the end of the compound tells me that it's kind of off to the end of the molecule. So I put my 6 valence electrons around the oxygen. And then I've got the other hydrogen, remember that we said that had to be bonded to the oxygen because of the way it's written. So then we draw our last couple of bonds here. So the carbon gets bonded to the oxygen, fantastic, and then the oxygen gets bonded to the hydrogen. Okay? And if we wanted to clean that up real quick, we would get this molecule. Okay, we've got carbon, carbon, oxygen. You can draw the hydrogen, it could be down or up or straight out to the side. It doesn't really matter that much at this point. If you take some higher level college classes like organic chem, some of that stuff will start to matter a little bit, but at the level that we're doing it, it really doesn't. So this is what I've got. We should do a quick check just to make sure that our electron count and everything like that is all right. So I've got 8 from the hydrogens, or I'm sorry, 8 from the carbons, plus 5 is 13, plus 6 from the oxygen, so that's 19, plus 1 is 20. So do I have 20 electrons? Okay, 2, 4, 6, 8, 10, 12, 14, 16, and you're like, oh, I don't have enough. But remember, we've got lone pair electrons here that we didn't draw, okay, from right here. Okay, so we do have 20, so we're in good shape there. And then are we following the octet rule? So 2, 4, 6, 8, yes. 2, 4, 6, 8, yes. 2, 4, 6, 8, yes. Everybody's following the octet rule, and so everybody's pretty happy. Okay? So hopefully that clears a few things up. I tell you what, I'm gonna do one more real quick just to show you that sometimes you can have double bonds in the middle. So let's do something like C2H4. Okay, so I've got 2 carbons, 4 valence electrons, right? And I've got 4 hydrogens, and so I start to line the hydrogens up like I normally would around the outside, but what I kind of realize is that I don't really have enough to fill in all the slots, right? I kind of need 6 to fill in all the spaces, but I don't have 6. Okay, and that's all right. Let's go ahead and do our bonding. So we bond all the singles together. Okay, and then the last thing is we notice that we're not following the octet rule with these carbons. We've got 2, 4, 6, 7, 2, 4, 6, 7. Not happy. I've got the right number of total electrons, but I'm not valence happy or octet rule happy. So simple thing. What do we say we usually do with the single electrons? Bond them together. So that means I've got a double bond then between the carbons. Okay, and so we draw that with a double bond between the carbons, and then we draw the hydrogens. Now, someone wants to ask, does it matter where I put the hydrogens? Again, at this point, not really. As long as I had 2 on each carbon, it wouldn't matter if I had like 1 down or up and down and nothing on the end, whatever. That wouldn't really matter. What does matter is that I've got enough and that everything follows the octet rule and all that. Okay? So we're going to work through a bunch of these. This is something that is really important that you practice, and at every step, make sure you count the total electrons, okay? And make sure you satisfy the octet rule for everything but hydrogen. Hydrogen gets 2, and that's still noble gas core. All right? Thanks, guys.